Let's look at some constructions that involve the golden ratio. So our first construction will be to construct the golden ratio starting with a golden rectangle. So this is a golden rectangle. If we look at the dimensions of the two sides of the rectangle, this longer side is about 1.618 times longer than this shorter side. Now this is the construction that you saw in the Donald Duck video. So the first thing we're going to do is measure the length of the shorter side. And remember, we measure by using our compass and putting the point of the compass on one of our endpoints and the pencil on the other. In my case, it's a marker. Now what I want to do is use that measurement to define a square. So I'm going to put the point of the compass on this vertex and make an arc, and on this vertex and make an arc. Now where those two intersections are, I have points defined that are the same distance from the corners of this rectangle as this distance was from here to here. So what I've got is a square. Now if you look over here, we have a rectangle, and this rectangle is another golden rectangle. So this longer side is 1.618 times longer than this shorter side. Now I could continue this construction to get another golden rectangle. All I would have to do is find a way to define a square, let's say right here. So I'll take the point of the compass and the pencil and use it to define the length of the side of this square. Then I will mark that length on these two line segments. If I connect those intersections up, then what I have is my second golden rectangle now divided into a square and a third golden rectangle right here. So this length is about 1.618 times longer than this length. And we could keep doing that forever and ever and keep creating golden rectangles. So in our second construction, we're going to start with a square, and then we're going to construct a golden ratio that we will be able to see in a golden rectangle that we've created that contains that square. Alright, so here's our square. Now the first thing we want to do is find a length that is 1/2 of the length of the side of the square. In other words, we need to bisect one of the sides of our square. So I'm going to choose to bisect this side. That's a construction we've done before. So I'm going to stretch the compass a little more than half the distance across that side. I'm going to make an arc above and an arc below. And then without changing the setting on my compass, I'm going to make an arc above and below. I don't think you can see the arcs below. You're just going to have to trust me that they're there. And I'm going to use those two intersections to define the midpoint of that line segment. So now I know how long a side of the square is, and I also know how long half the side of the square is. Now the next thing I'm going to do is extend both the top and the bottom sides of this square. So I'm just going to use my straight edge and just extend this, and up here extend this side. Now we know that we still have parallels, even though we've extended, because these two sides are parallel. Alright, so the next thing we want to do is use the compass to measure the distance from this intersection where we bisected the side of the square up to this corner of the square. And what we're going to do with that is make an arc, and notice the point of the compass is still down here at this intersection. Make an arc that intersects both of these extended line segments. So it's going to intersect this vertex and this extended line segment. Alright, now if you look at the distance from, and let me just label these so we know what we're talking about. Let me call this A, and let me call this B, and let me call this one C. Alright, so what we've got are basically 3 vertices of a rectangle. We simply need the 4th one up here. So what I'm going to do is take my compass and measure this distance. And I'm going to come up here to this vertex and measure that same distance. So now, if I connect these 2 points where they have this intersection, which I think I will label D, and point C, now I've got a rectangle. And in fact, if you look at this large rectangle, what I have here is a golden rectangle. So this longer side from A to C has a distance that is phi times as long as the distance from A to B. So the next construction is called Hero's construction, and we'll be using a right triangle to construct the golden ratio. Alright, so here's our right triangle. Let me just label some of these points so that we can refer to them. I'll call this one A, and I'll call that vertex B, and I'll call this one C. So what I want to do is take this line segment from A to C and divide it somewhere so that I can see the golden ratio in the lengths of the segments that I've divided AC into. So to do that, the first thing I'm going to do is take the compass and measure the distance from B to C. So it looks like it's about that long. Let me There we go, that's pretty good. Alright, the next thing we're going to do is with the point of the compass on point B, we're going to make an arc that's going to go through point C, and we want that arc to come up here and intersect segment AB. Now we're going to come over here to point A, and we'll use the compass to measure the distance from point A to this intersection alongside AB. And now we'll make an arc like this. Let me call this point D. Alright, so we don't have a rectangle this time, so it's a little harder to see that golden ratio. But the golden ratio exists down here on this line segment. If you look at point D is dividing segment AC into the golden ratio. So if we would make a ratio of the length of AC to the length of AD, that would be equal to the ratio of the length of AD to the length of DC. Our last construction will be to construct the golden sequence. So what we're starting with is a line segment that has some points placed on it at some specific distances. So we're going to call the distance from A to B 1 unit, and we're going to call the distance from B to C phi units, because this distance from B to C is about 1.618 times the distance from A to B. If I want to construct a segment that is phi squared units long, what I'm going to remember is that phi squared is the same thing as 1 plus phi. So this distance measures, or this segment measures 1 unit, and then this one measures phi units. So to find the sum of those distances, I'll just take the point of my compass and put it on A, and put the pencil on C. So this distance is 1 plus phi, which I can now transfer over here. I'll call this point D. So this is 1 plus phi units, which means it's phi squared units long. Now I don't quite have enough room here to show you the whole thing, but if I wanted to make a segment that was phi cubed units long, I would have to sum phi and phi squared. So I would simply find this distance. That distance is phi cubed. Don't quite have enough room to put it over here and show you, but I could, if I had a long enough line segment, extend this, but this is still the distance. Remember, you can only get good at constructions by practicing them. You can't just watch somebody do it once or do it yourself once and know everything about the constructions. You have to practice them several times before you can remember what you're doing. So practice the constructions, and then there is a homework assignment for you to do on My Gateway that you will need to do and print out and do and bring to class with you and turn it in at the beginning of class.